Hello everyone, I hope you are doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is winner of an election, and it is an easy level problem. So the problem is very simple. It says that we have been given some people, the names have been given, and we have to find out the person with the most number of votes. So each occurrence of that particular person in the array like represents one vote. So basically we just have to count the frequency of all the people in this particular array, right? And in case two people have the same number of votes, and if there is a draw or more people have same number of votes, we have to print the lexigraphically smallest one, right? So this is the whole conditions for this particular problem. The problem is very simple. I don't think I need to explain this. I'm just going to go through the code. I have created an unordered map of strings comma integers. So the first part will be a string, key will be a string, and the value will be an integer, which is the frequency itself, right? Now since the time and space complexity required is O of n, that is why I took unordered map. It can take O of n time for accessing the elements in the worst case, but in the average case it works in O of 1 time, and hence the total time complexity will be O of n only, right? I'll tell you in a while how is it like this. So first of all, what I do, I just traverse through the whole array and I increment the frequency of each of the array items. Now I create my best value, which is the maximum number of votes that I've got till now, and I have created a like answer vector of size 2, because we have to return the answer in a string, and the answer should be, the first part should be the person who has won, and the second part should be the number of votes, right? Now what I do, I just traverse through the votes map, and if the current frequency is greater than the best frequency, then I directly update my best frequency. I update my answer of 0, that is the name of the person, with I dot first, and I update the number of votes by converting this best into string format, right? Because the vector initially was string. Now if this condition is not satisfied, else if I have this particular condition, if the current frequency is equal to the best frequency that I had, right? This means that this is a draw, and the current person has a lexicographically smaller name than the person who is currently sitting in the answer, right? So in that particular case, I'm just going to update my answer of 0, and this will be my final solution. At the end, I return my answer. So you see, I am trying to access uh, or update the map here, right? I'm incrementing the frequency of the map, and I'm doing it n times. So if the time complexity of accessing or updating the map is O of 1, the overall time complexity will be O of n. But in the worst case, if it goes up to O of n, the accessing time complexity, then the overall time complexity of another map becomes O of n square in this particular case, right? But you can also use map, and in that case this time complexity will be n log n, because each accessing operation or each updation operation will take log n time, and n is for the this particular for loop, right? So this was all about this particular problem. I hope that you guys were able to understand the solution. If you guys did, consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this video really helps YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So before signing off, let me just quickly submit this and show you that this particular solution works. So you see, it passes all the test cases and the solution is correct. I hope that you guys were able to understand the solution. If you guys did, then again drop a like. Till the next video drops, keep coding, stay safe, bye bye.